हेलो फ्रेंड्स, वेलकम टू डिजायर एकेडमी यूट्यूब चैनल। पिछले क्लास में हमने रिंग थ्योरी के कुछ थ्योरम और कुछ पोस्टुलेट के बारे में बात की थी। इस क्लास में हम एक प्रीपोजिशंस के बारे में बात करेंगे जो कि इम्पोर्टेंट है और बीएससी में आपके क्लास में या फिर एमएससी में भी पूछी जाती है और ये एक रिजल्ट है, उसकी तरह हम याद रखेंगे। सो द प्रीपोजिशन इफ आर इज अ रिंग सच दैट द गिवन पोस्टुलेट दैट a square equal to a for all a belongs to R, then prove that these three postulate. First one is a plus a equal to 0 for all a belongs to R. A plus b equal to 0, this implies a equal to b, and R is a commutative ring. So we can prove these three postulate one by one, but the given condition is a square equal to a for all a belongs to R is very much important. So let's start from the first. So we have to prove that a plus a equal to 0. Now a square equal to, since a square equal to a for all a belongs to ring R is given. Now if a belongs to R and R is a ring, okay, R is a ring, so a plus a is again belongs to ring R. Now a plus a the whole square equal to element itself. If a belongs to R, then a square equal to a, and here a plus a belongs to R, so a plus a the whole square equal to a plus a. So if I simplify this bracket, then we have a plus a into a plus a, this is equal to a plus a, a plus a. Now if I more simplify, a plus a into a, this is equal to a, and in a ring we can multiplication over addition is distributive, so here we have a square plus a square plus a square, this is equal to a plus a. Now here a square equal to a, so we can put that here a plus a plus a plus a, this is equal to what? A plus a. Now a square equal to a we use here. Now if this is the first bracket and this is the second, then we know that a plus 0 equal to a for all a belongs to R, so I can add here plus 0. Now in a ring left cancellation law holds, so by left cancellation law, if I cancel this a plus a to this a plus a, we have a plus a equal to 0, and the first one postulate is proved. Now to going on second number postulate, it is easy if we use this first postulate. The second is a plus b equal to 0. We have to prove that a plus b equal to is given. We have to prove that a equal to b. Now in one, a plus a equal to 0, and by 1 a plus a equal to 0. So if a plus b equal to 0 and this 0 can be put as a plus a, so we have a plus b equal to a plus a, and by left cancellation law again we can cancel a from left hand side, we have b equal to a, and what we have to prove is already we get it. The third is R is commutative ring. So in 3, let me change the color of a pen. So we have to prove R is commutative ring. Now that means for all AB belongs to ring R, we have to prove A into B equal to B into A. ये हमें प्रूव करना है, ठीक है। नाउ हमें फर्स्ट और सेकंड में जो हमने प्रूव किया उसका हम यूज करेंगे टू प्रूव दिस. वी नो दैट A and B belongs to R. Let A and B belongs to R, then A plus B is also belongs to R. Okay, and a square equal to a is given for all a belongs to R. So if a plus b belongs to R, then a plus b the whole square, this is equal to a plus b. Again I simplify this bracket, then we have this a plus b into a plus b equal to a plus b. Again a plus b into a plus a plus b into b, this is equal to a plus b. So here a square plus b into a plus a into b plus b square, this is equal to a plus b. Now here a square equal to a if a belongs to R, and here a and b both belongs to R, so we can put a square equal to a, here b into a plus a into b, and this b square equal to b, so b, this is equal to a plus b. By left cancellation law I cancel a, and right cancellation law I cancel b, so we have b into a plus a into b, this is equal to 0. But in 2, if a plus b equal to 0, then we already proved that b equal to a, so by 2 b into a plus a into b equal to 0, so we can say that a into b, this is equal to b into a, and what we have to prove here. So हमने यहाँ पे ये जो थ्योरम है वो प्रूव कर लिया है. आई थिंक आपको अच्छे से समझ में आ गया होगा. और ये एक कंडीशन है, अगर रिंग के साथ अगर होल्ड करता है तो वी कैन से दैट a प्लस ए इक्वल टू 0. इसका मतलब हुआ कि एवरी एलिमेंट a is its own additive inverse, and if a plus b equal to 0 then a equal to b and a square equal to a, this implies R is a commutative ring. So this example is show that the set of numbers of the form a plus b root 2 with a and b as a rational number is filled. So in this question we have to show the special set. If I say R is equal to set of the form a plus b root 2 where a and b belongs to set of rational number, that is q, is filled. We have to prove that is filled. This is the question. So to show the field, हमने ऑलरेडी डिस्कस किया है कि फील्ड क्या है और वो क्या कौन कौन से डेफिनेशन को होल्ड करता है. ठीक है, तो उसी पोस्टुलेट को हम यहाँ पे सेटिस्फाई करेंगे. So if I choose two elements from this set R, so let a1 plus b1 root 2 and a2 plus b2 root 2 belongs to R, and here a1, a2, b1 and b2, this belongs to the set Q. Okay, set of rational number. So now we have to define addition and multiplication. So we have a1 plus b1 root 2 plus a2 plus b2 root 2. So this is equal to, if I add a1, a2 and b1, b2 common, then we have here root 2, and also a1 plus b1 root 2 into a2 plus b2 root 2. If I simplify this, a1 into a2, so I have a1 a2, if a1 with b2 root 2, here b1 root 2, so b1 a2 root 2 plus root 2 into root 2, I have 2 b1 b2, so this is equal to a1 a2 plus 2 times b1 b2 plus a1 b2 plus b1 a2 into root 2. This is how addition and multiplication are defined. If I say a1 and a2 are from rational, then addition of a1 a2 and b1 b2, so this is the element of our ring R, and the multiplication of rational number is again rational number, so this element is belongs to Q and this is belongs to Q, so both belongs to Q, so the whole number is belongs to R. by the definition of set R. Now all the elements of R are real number, and we know that the addition and multiplication are both associative as well as commutative composition in the set of real numbers, because this element of ring R here, element of set R is a real number. So if I write here element of set R, elements of set R are real number, and addition and multiplication are both associative and both are associative as well as commutative. Composition in the set of real numbers. Okay, so this is the what we don't have to prove here, that the associative law and the with respect to addition and compositions, we have now directly go on zero element or the identity element with respect to addition. We know that 0 belongs to Q, so this implies 0 plus 0 into root 2. This belongs to set R, and if we have a plus b root 2 plus, if I add this with 0 plus 0 root 2, then this is equal to what? 0 plus a plus 0 plus b into root 2, and this is a plus b root 2. So 0 plus 0 root 2 is identity element of with respect to addition. Okay, so we have additive identity here. Again, if if a and b, a plus b root 2 belongs to R, this means that where a and b belongs to Q. Okay, where a and b belongs to Q. Now if a b belongs to Q, then this implies minus a and minus b belongs to Q. Okay, so minus a and minus b belongs to Q, so this implies we have minus a minus b root 2 belongs to set R. Okay, now if I add these two elements, so here if a plus b root 2, if I add plus minus a minus b root 2, this equals a plus minus a and plus here b plus minus b root 2, so this implies here is 0 and 0 root 2. So this is the additive element or additive identity element of the set R. Okay, so this implies that if any element AB belongs AB root 2, then we have the inverse element with respect to addition element. So here we know that the set of each element of R possesses additive inverse. Element. So we done. Now the set of real numbers multiplication is also distributive with respect to addition? We know that the set of real numbers multiplication is distributive over addition. So with addition, so now we have to here prove this all. Now again, if we know that 1 plus 0 root 2 belongs to R, so to prove we have to prove the various postulate. If I prove here that the unity element with respect to multiplication is in set R, so if I have 1 plus 0 root 2 belongs to R. Now if a plus b root 2 is any element, and if I multiply this a plus 0 root 2, then this is equal to what? A plus b root 2, and this is the set of element, that is unity element 1 plus 0 root 2. This belongs to set R. Okay, or we can say that it is a multiplicative unity. Okay, now R will be filled if each non-zero element has a multiplicative inverse, but we have multiplicative here unity. Now to prove R is filled, each non-zero element has multiplicative inverse. So if let A and B belongs to Q and non-zero, this implies that A plus B root 2 belongs to R is any non-zero element of set R. Then at least here A and B belongs to Q, then one of them, either A or B must be non-zero. Okay, so either A or B must be non-zero. Okay, that means, so if we have to find that the inverse of A plus B root 2, so if I take A upon A plus B root 2, so this is equal to A minus B root 2. If I multiply by A minus B root 2, then A plus B root 2 into here A minus B root 2, this is equal to A minus B root 2 upon A square minus 2b square. If I simplify this, that I have A square minus 2b square. So this is equal to A upon A square minus 2b square minus B upon A square minus 2b square root 2. Now A and B are rational number, then maybe we can have A square equal to 2b square. Okay, so here A and B are rationals. Then we have इनवर्स हमने निकाल लिया, बट a अपॉन ए स्क्वायर माइनस 2b स्क्वायर, और यहाँ पे जो है उसमें डिनोमिनेटर जो है वो 0 नहीं होना चाहिए. सो a स्क्वायर माइनस 2b स्क्वायर इक्वल टू 0 एंड ab बिलोंग्स टू q, रेशनल नंबर. सो दिस इज ओनली पॉसिबल व्हेन a इक्वल टू 0 एंड b इक्वल टू 0. बट हमने यहाँ पे क्या लिया है, इज नॉन जीरो एलिमेंट, दैट मीन्स आइदर a और b must be non-zero. So this is the only possible, since here at least one of the rational a or b must be non-zero. That means a square minus 2b square is not equal to 0 if a not equal to 0 or b not equal to 0. That means existence of this is exist. So here this element a square upon a square upon a square minus 2b square and minus b upon a square minus 2b square, this belongs to q, and so this elements belongs to R. If I write here a upon a square minus 2b square minus b upon a square minus 2b square root 2 belongs to R, and this is the existence of multiplicative inverse for non-zero element. That means for each non-zero element multiplicative inverse is exist. So this is the for all the postulate what we have to prove for field. So this means R plus dot is field where R is the set of the form a plus b root 2 where a and b belongs to q. So ये जो सेट है वो हमारे पास क्या है, फील्ड है. सिमिलरली वी कैन प्रूव दैट यहाँ पे जो अगर सेट ऑफ रेशनल नंबर है उसकी जगह पे अगर हम सेट ऑफ इंटीजर ले ले. सो दिस इज द क्वेश्चन फॉर यू एंड यू कैन कमेंट द आंसर. इफ R is equal to a plus b root 2 and a and b belongs to say set of integer, is field or not? Is it integral domain or not? ये भी आपको कमेंट में आंसर देना है. तो आई होप यू लाइक दिस क्लास एंड इफ यू हैव एनी डाउट देन प्लीज कमेंट. अगर आप हमारे यूट्यूब चैनल पर नए हो तो सब्सक्राइब जरूर कर लीजिए. मिलते हैं अगले वीडियो लेक्चर में. टेक केयर एंड गुड बाय.